Hi, I am Abhishek Cherikar. Today we are going to learn about circular doubly linked list along with its insertion, deletion, and how traverser, the list, search, etc.
Circular doubly linked list. A circular doubly linked list is a data structure that allows for efficient insertion, deletion, and traversal of data. It's a variant of a doubly linked list where the last node points the first node and creating circular loop. The circular nature offers the advantage over traditional linked list, making it suitable for various applications. Let us see how we can represent a circular doubly linked list. In the structure of doubly linked list, each node is in a circular doubly linked list holds three components: data, the value to be stored; previous holds the memory address or reference of previous node in linked list; next holds the memory address of or reference of the next node in linked list. Unlike the other singly linked list where the next of a last is null, where doubly linked list uh, of a previous of a head and next of a tail node is null. In circular doubly linked list, the next of a last node points the head and point previous of a head node points the last node. Below, the image can be represented as a circular doubly linked list. Let us see with this an example. Let us take a linked list of a 4 node with data A, B, C, D. The pointer of a node D would be to the node A and the of a previous of a node A would be point to D. This creates a circular loop.
Let's move to the next topic, that is traversal. In simple words, traversal means visiting every node present in linked list. Step 1. Select one node from we can start the traversal. For now, let's select the head node. Beginning the traversal from the head node, this node is starting point to access all the other nodes in the circular linked list. Step 2. Process the node. In this step, we have the access to the node. After accessing the node, we will print the data present in it. Next, step 3. Move the next node. After printing the data present in the node, we will move to the next node with the help of next pointer of the current node. Step 4. Check for AND. Check if the current node is the same as the head node. This condition is true when you have traversed the entire list and returned to the starting point. This indicates the end of the traversal. Step 5. Repeat 2 and 4. Continue step 2 and 4 until the end condition is met. Repeat the process of the processing the node data, moving to the next node and checking for the end condition. This iterative process ensures that all the nodes are in the circular list are visited and processed. Next, search in CDLL, circular doubly linked list. Searching in circular doubly linked list is same as searching in the other linked list. First, we have to traverse through the linked list and complete the target data with the data present in the current node. If the target data and the data present in the current node matches, then we have say search is successful and search value is present in linked list. If the target data and the data present in current node does not matches, then we will move to the next node and compare the data. If after this whole process, if we come back to head node, we can say that traversal is complete and target data, which is our search value, does not exist in the linked list.
Insertion in CDLL. In circular doubly linked list, insertion can be performed in three ways: insertion at the beginning, insertion at end, and insertion at the middle. Let's see this within one example. Here we have CDLL having four nodes: A, B, C, and the D node. Along with it, we have a new node E. whose previous and next pointers are null, and we are supposed to insert this new node in CDLL at the third position. So the step 1 is to create a new node and assign a desired value to it. Step 2 is to determine where we have to insert it. Here we have to insert it at the third position. In step 3, we have to adjust the pointers of the surrounding nodes to include the new node in the linked list. And at last, in the step 4, we have to link the nodes to complete the linkages. That is, the next pointer of the second node points to the new node, and pref of the previous third node should point to the new node. Same for the new node. Its next should point to the previous third node, and the previous should point to the second node. Here, we can see after insertion, new node is inserted in the linked list at the third position. For insertion at beginning, if the new node is being inserted at the beginning, the next pointer of the new node is set to the current head, and the previous pointer of the current head is set to the new node. The next of the tail node set to the new node, which is supposed to be inserted, and prev of new node set to the tail node. Now, the head node should be updated to the new node. For insertion at end, if the new node is being inserted at the end, the previous pointer of the new node is set to the current tail, and the next pointer of the current tail is set to the new node. The tail node is updated to the new node. The previous of head is set to new node, and the next of the new node is set to head.
Let's see deletion in circular doubly linked list. In circular doubly linked list, deletion can be performed in three ways: deletion at beginning, deletion at end, deletion at middle. Let's see this with one example. Here we have CDLL have four nodes A, B, C and D node. Here we supposed to delete the B node from the CDLL. Step 1 involves identifying the node which we want to delete, and it could be head, tail or any node in the middle of the list. Here we are deleting B node. Step 2 involves the updating of pointer, in which we modify the pointer of the node before and after the node being deleted to bypass the deleted node. Step 3 is to see the both the pointers of removed node to null to indicate that this node does not belongs to the list. Let's see to delete the head node. If the head node is being deleted, update the head pointer to the next node in the list. Additionally, set the previous pointer of the new node to the tail node and the next of the tail node to new head node. This ensures the circular structure is maintained. To delete at the end, if the tail node is being deleted, update the tail pointer to the previous node in the list. Additionally, set the next pointer of the tail node to the head node and the previous of the head node to the tail node to maintain the circularity. Let's see advantages of circular doubly linked list. First advantage, efficient traversal. You can traverse the list in both direction, forward and backward from any node. This is because each node points to the previous and the successor next node. Second advantage, easy insertion and deletion. Insertion and deletion operations are simplified because you only need to update the pointers of the surrounding node. This avoids the need of searching through the entire list. Third advantage, efficient circular structure. The circular nature of the list eliminates the need to handle the end of the list explicitly. Once you reach the last node, it automatically loops back to the head, making the circular. Fourth advantage, representation of data. Circular doubly linked lists are ideally for application where data need to be accessed in a specific order or need to be organized into circular structure. This is common in data structure that represent circular queues or circular buffers.